sorry, x0 1 plus x1 1 plus x2 1 and so on, like this. Is it clear now? So x, when I look this from this angle, this is xn, this is x0n, and this is x7n. So see how the things are. So what I am trying to represent every point or every sample or every element of my original signal xn as summation of 8 points, 8 elements or 8 samples. Each of them is 2-dimensional. So it's a 2-dimensional summation. Means you can sum one dimension, you can sum other dimension, and there is the result. So x0 is summation of 8 samples. x1 is summation of 8 samples. So when I look at xn, what I say? Xn is a sequence which is, or it's a point moving with respect to n. Xn is movement of point with respect to n. Everything in this, there are now 72 entities. These 8 and these 64. Every entity is a point. Every entity is a point in 2D plane. So when I look at xn, means when I try to look at these 8 points collectively, what I look at? I look at movement of point with respect to time, or with respect to n. Right? Then, when I look at this, what I look at? For 0 or the constant, so they don't move. They don't move. There is a difference between my looking for this particular and the others. So for this, when I look at this, x0n presents me all point means steady points. x0n is a steady sequence. x0n doesn't move. So this moving sequence I am trying to look at as summation of, and that is equal to, this is also summation, x in general, x0n plus x1n plus 1. Right? So each of them is a sequence, each of them is a movement in a particular manner. This is a movement, general movement. Xn is the original signal. So Xn represents me the movement of point under interest. Of that, x0n provides me a component or a sequence which is a steady sequence. What x1n will provide me now? Now x1n will provide me very interesting thing. What is that which we are now considering? x10, x11, x12, x13 up to x17. So what that is? The sequence x1n. The sequence x1n is generated. Actually, this sequence is generated only from the capital X0. This sequence is generated only from capital X1. How we can say capital X0? Means we had got capital Xk as a 8-point sequence that we divided into subsequences capital X0k, capital X1k up to capital X7k. What capital X0k was? Capital X0k was containing capital X0 and all other zeros. I hope that might be available if you have noted down something on at the last lecture. Capital X1k represents 0, capital Xk and all zeros. So what is X0n? X0n is the inverse DFT of X0k. X1n is the inverse DFT of X1k. So what is X1n? X1n is now X1n is a well-defined, is a function of n now. This is not a function of n. Xn you cannot write as a function of n. If means when a liberty was given to you to have anything for Xn, can you write a formula? No. So to represent Xn, you have to represent all n points, all capital N points or all 8 points. So there is no possibility for us to write Xn as a function of n. Whereas now X1n will be a function of n, and what that is? That is X1n is X1k, not X1k actually, it is X1. You can have IDFT. 1 by 8 will come into picture here first. 1 by 8 X1 into Wn raised to minus k, where k is 1. Wn is what? Right now W8. That is this point. W8 is this. W8 raised to minus 1 raised to n. W8 raised to minus 1 is this point. So X1n is equal to X1 upon 8 into e raised to j pi by 4 raised to n. So X1n is now a well-defined function of n. So this would be some constant, and this will move at an angular speed of e raised to minus j pi by 4. This will move at an angular speed, actually not speed of e raised to minus j pi by 4. This will move at an angular speed of pi by 4. Are you getting me? So it is straight away the phasor of this magnitude is 1. This is the magnitude. Phasor of X1 upon 8 moving at a rate of pi by 4 as a discrete angular speed. Pi by 4 is discrete angular speed. Today we will be engaging in continuation.
Break. Break. Break.
So W8 raised to minus 1. I had allowed you enough time as a comfort break of 2 minutes. In, in order to enable you to concentrate again. If ever there is a need of another comfort break, that I will decide suitably. Now, W8 raised to minus 1 happens to be raised to j pi by 4, and that raised to n. So this particular thing is a phasor rotating at a speed of at an angular discrete speed of, or at a speed of pi by 4 per sample. This corresponds to a phasor rotating in anti-clockwise direction at an angular speed of pi by 4 per sample, and this tells me what this tells me?
Magnitude of phasor.
What?
Magnitude.
This tells me magnitude of the phasor is not a complete statement, in the sense that x1 is not necessarily one dimensional. So, if I put n equal to 0, what will happen? This will be 1. If I put n equal to 0, this will be 1. Then I will get something for x1 upon 8. So x1 upon 8 will be indicating me what? X1 upon 8 will be indicating me the value of x1n at n equal to 0. And when n changes, the phasor will move by an angle of pi by 4. So capital X1 upon 8 is the initial position of the phasor. When I say initial position of the phasor, it includes the amplitude as well as the phase at 0. So if x1 is real, in that case it will give you only amplitude, because phase at 0 is 0. That means what I can say, if x1 can be 1, if x1 is 2, what will happen? Let us say if x1 is 2, in that case it is 2 by 8. So in a 2D plane it is 1, so 1 4. This is the initial position. This is the initial position. So what would be x1 1? From this position now you will draw a circle, and it will rotate by pi by 4 each time. So if this is x1 0, x1 1, x1 2, x1 3, x1 4, x1 5, x1 6, x1 7. So what I look at, x1n is a sequence which is having an angular speed of pi by 4. Now see what I am successful in. I am successful in representing my sequence xn as summation of first a steady sequence with some value, then a sequence rotating at an angle of pi by 4 with some value. What is that? Maybe 2 by 4. If x1 is 2 plus 2z, what will happen? If x1 is 2 plus 2z, what will happen? It would have been 1 upon 8, means 1/4 and 1/4. So its amplitude would have been more. So this is amplitude, and this would have been x00. This is sorry x10. X. This is x10. Then a bigger circle would have been there. x11, x12, x13. Is it clear? So x1n represents a sequence in which I am having an angular speed of pi by 4 per sample. All these sequences have one thing in common, that amplitudes of all are constant for all n's. Magnitude means now the general movement which I was having of xn, means I am trying to represent a general movement of xn by summation of 8 specific movements. What I am trying to do, I am trying to represent a general movement of 8 points of xn as summation of 8 specific movements. Now what is x2n? What is x2n? x2n. What is x2n? x2n again would be a phase. The movement of x2n is the phasor movement with angle pi by 2 per sample and some fixed amplitude. So this xn, wherein I was having magnitude as well as phase variation, means there was no restriction on xn. So x0 can be anywhere, x1 can be anywhere. So both magnitude and phases were changing. This general movement I am writing as summation of specific movements. So if a all steady sequence, this is all steady sequence, a sequence with some constant magnitude and angular speed of pi by 4 per sample, sequence with another constant magnitude and pi by 2 per sample, then 3 pi by 4 per sample, then what? Pi per sample, then 5 pi by 2 per sample, or 5 pi by 2 per sample, or minus 3 pi by 2 per sample. Sorry, 5 pi by 4 per sample. First all steady, then pi by 4 per sample, pi by 2 per sample, 3 pi by 4 per sample, pi per sample, 5 pi by 4 per sample, or minus 3 pi by 4 per sample clockwise, then minus pi by 2 per sample and minus pi by 4 per sample. You can look as you wish. So this is a general sequence is written as summation of 8 specific sequences. One general sequence is written as summation of 8 specific sequences. Now naturally one will ask, what is the advantage of this? What is the advantage of this? Whether anybody of you would be in a position to give what is the advantage? disadvantage. I hope that you have not forgotten that we had also discussed the discrete time systems. Is it right? We had discussed discrete time systems. So what discrete time system is? Which works on discrete samples. So simple discrete, in discrete time systems we had also said that there are two types. What those are? Not causal and anti-causal, non-causal, like this. Simple. Stable and unstable. And FIR and IIR means in a discrete time system, the current output is a combination of past inputs or current and past inputs and maybe past outputs. So what is the simplest, most discrete time system which we also consider? That was Yn is equal to xn plus xn minus 1 upon 2. That is the average of current and previous sample. Is simple mode system. Yn is xn plus xn minus 1 upon 2. So, if we apply input to such system, then what would be the output? What happens actually is that, what is the output in this case? Current and previous sample average, and you may plot, you may take a 64-point sequence, ideally infinite, but let us be finite. 64-point sequence you can take, and you can plot the xn, y. Each. Now let us keep it a habit to think in two dimensions, even though that may not be required, because reverse is any time possible. Two-dimensional thinking with other dimension to be 0 is very easy to come to one-dimensional. But from one-dimensional means, if you are, what we can say, well practiced to think in one-dimensional, then to develop your two-dimensional thinking is very difficult. But if you are well practiced in two-dimensional, you can think one-dimensional at any point of time by considering the other dimension to be 0. So what happens is, the time sample domain description, xn we apply, yn we get. So what exactly is the relationship between xn and yn? We cannot we are taking comfort break, and we would also like to shift to other class or continue the same class?
Yes.